All right. Thank you so much for that kind introduction. And glad you got the WIDS podcast plug-in. Very important. All right. So today I'll be talking about racial disparities in automated speech recognition. And so to start, let's talk about what this actually means. So this is based on a paper done by a very interdisciplinary team of linguists and mathematicians and computer scientists. But let's try and parse what the title of this talk is, right? So we're talking about automated speech recognition, which I'll be calling ASR, but what actually is that? You can just think of this as speech to text. So for example, things like Alexa, Siri, or Google Home, where you say something and they transcribe what you say. So these might seem like kind of a low stakes kind of application area to be thinking about with regard to racial disparities. But in fact, there are lots of application areas where it really matters to get these right. So for example, ASRs are used as digital device interactive modes for individuals who maybe want to speak to their devices instead of interacting with them with, say, their hands. They are used in car systems. They're used by doctors because there are some specifically trained on medical jargon kind of handheld devices that you can use as a doctor to record your patient notes. And they're used as court transcription services. And so you can imagine that the consequences of ASR technology might be biased if the underlying ASRs are biased. So the real question here is, what are the impacts downstream if, say, court transcriptions are only accurate for white defendants, but not for Black defendants? So obviously, this is an important problem. So now let's turn to discussing what we actually do in this paper, which is auditing 5 different companies' ASR systems. So who are we auditing? Hopefully you recognize these logos. We'll be evaluating 5 different firms for their transcription services using the consumer-facing APIs that they offer. And so to be clear, we aren't looking specifically at, for example, the racial disparities of Siri or Alexa, but rather the paid services that are offered by each of these 5 firms that allow for batch transcription. So the idea is we take a bunch of, say, like .wav files or MP3 files and run them all through these services and then compare their performance. So with that, let's take a step back and ask, is there any precedence for doing this sort of auditing? And the answer is yes, in the computer vision domain. So facial recognition has been found to perform much worse for women with darker skin tones. And there have been lots of implications from this work. So in particular, in 2020, with the Black Lives Matter protests, this work actually led to Microsoft and IBM no longer selling their facial recognition technology to police departments. And so you might ask, well, these seem pretty impactful. Why aren't there more of these sorts of studies? And the issue is that you kind of have to be a bit clever in doing these sorts of auditing studies, especially if you're doing them externally where you don't have access to the underlying machine learning tools that are being produced by these companies. So let's start by talking about the data that we use in our study. So again, we're thinking about automated speech recognition. And so of course we need some audio data. In particular, we're going to be using 2 different sets of sociolinguistic interviews. So one is called Coral, which is where our Black speakers are sourced from, and the other is called Voices of California, which is where our white speakers are sourced from. And the question here is, well, what exactly are sociolinguistic interviews? They're a very convenient source of data if you work with linguists, where basically some linguistics grad student goes and collects a ton of interviews with different speakers where they're asking a kind of standard slate of questions. So the interviewer, our linguistics grad student, might ask things like, where did you grow up? What types of jobs did your parents have? How do you feel about, certain topics? What types of games did you play when you were a kid? And based on that standard slate of questions, the interviewees will then respond in kind of a free-form basic conversational style, which is really great because then we can take the interviewees' responses as kind of basic conversational dialogue. There is, in fact, a lot of other voice data out there, for example, on Wikipedia, which is just read speech, where individuals are given, words to read, and then they go ahead and read them. But that's not the type of data we want to use because it's not conversational. It doesn't flow like a usual conversation might, especially if you're speaking to an ASR and asking it to do something like find a recipe or play a song. That's going to be much more conversational. So we stick to the sociolinguistic interviews. So based on that audio data, Why do I say these sorts of auditing studies are kind of few and far between? Because you have to be a bit clever, because you have to make sure that you aren't testing on training data. So if you don't know what any of these companies, these 5 companies, are training on for their data, you might be inadvertently trying to audit their study on data that they've already used for training, and so they'll get 100% and seem great, when in reality you're just doing something cyclical. So what we need to do is find unseen data in order to audit these systems, and this is exactly what we do. One of them, which is an entirely African-American corpus, we confirmed was not used specifically by any of these 5 companies, and the other one, Voices of California, was private to Stanford, so we know that none of these data sets were used as training data already. And lastly, I'll just make a note on the size of the data. So to computer scientists, this will seem very small. To linguists, this seems very large. We end up with about 40 hours of speech data. And pertinently, the other reason why it's really great to have sociolinguistic interviews is that our linguistics grad students who are going out there and interviewing people are also then painstakingly transcribing all of the resulting words, which involves things like having standard transcriptions for things like or laughter or pauses or cars going by, that sort of thing. So we have this really great time-stamped human-generated ground truth, which we see as basically our truth for what is actually being said. So from that audio data, we then do some processing. So what does that mean? We basically segment each of the interviewees' speech segments into continuous chunks. So broken up by the ends of phrases after a few sentences, if there's a pregnant pause, that sort of thing. And then we feed those smaller MP3 files, say, into each of the 5 firms' ASR products. One thing we do before doing that is propensity matching on a few different attributes. So things like age, gender, and duration. So we're making an apples to apples comparison between our set of Black speakers and our set of white speakers. So they'll be roughly similar in terms of the distributions of age and gender, which we know greatly affects your transcription abilities. All right, so what does that actually look like? We end up with about 2,000 Black snippets and 2,000 white snippets that are roughly matched on those specific traits that I mentioned. Then we feed all of them into a black box model of different ASRs, and each of those ASRs is going to spit out some transcription. Now, the question here that we want to figure out is, you have all of these transcriptions for the Black speakers and all of these transcriptions for the white speakers, but are they any good? So how do we actually determine whether these transcriptions are accurate? We have to introduce a metric. So the metric that we're going to talk about, and which is standard in use in the linguistics sphere, is the word error rate. So you can think of this as just the edit distance, but this is effectively the number of changes you need to make in order to get the transcription back to the ground truth. So for example, to go from "that is a presentation" to "what a great presentation," you need to replace that with "what," you need to delete "is," and you had to insert "great." So that's 3 changes out of 4 words. So that gives you a word error rate of about 75%. Now the question there is, is that good or bad? First point to note is that high word error rate is bad, low word error rate is good. I'll repeat that a few times throughout the presentation because it is confusing. So in general, when you think about what a bad word error rate is, if you transcribe something and you get every other word wrong, that's basically unintelligible. So that would be a word error rate of 50%. So anything higher than 50%, we can assume is basically unintelligible. So with that, what we actually see when we look at our breakdowns of our different demographics is we have roughly doubled word error rates, error rate of about nearly about 40% for Black men in particular, so very close to being unintelligible relative to say about 18% for white women. So again, it's hard to kind of understand what this means without listening to it, so I'll play you a few clips so you can hear what this sounds like. First, I'll play you a clip of the average white man, so someone with a word error rate of about 20%.
Well, when I was really young, I'd had a book of basketball statistics, and I would spend a lot of time reading them. And for some reason, I forget why now, but Jason Kidd ended up being my favorite player.
All right, so you can see from the red markings that those are the areas where the ASR transcription messed up in this particular voice sample. And so relatively few red markings, leading to this 20% word error rate. In contrast, this Black woman sample, you can already see there are more red markings. It does have a significantly higher word error rate of 30%, which again is worse. And so I'll play this now so you can listen and see if you think this was any more difficult to understand than the white man sample.
And she had these little like snow cone things. I don't even know what it was. But it's not like the snow cones up here. Like, I don't know how to explain it. But, you know, a bag of candy for a quarter, like a full bag of candy for a quarter.
All right, so presumably those were comparably understandable to any human listener, but for some reason, these AI are messing up on basically being able to transcribe correctly the second person's sample. And one other note that I'll mention is that this doubled word error rate that we saw across the board was consistent across all 5 firms that we evaluated. So we did see significantly worse transcriptions for Black speakers relative to white speakers. So this is kind of like the high level thing, right, that gets reported on is, oh my gosh, we have these like massive disparities. But the crux of the paper, and I think where the real meat is answering 2 separate questions, which I'll go into for the rest of the talk. So the first question is basically, how do we actually know that this is a race-based thing? Because a lot of people might ask, well, there are a bunch of geographic differences in the US. What if it's just people are talking differently for whatever other reasons you aren't controlling for? How do you know it's race? And the second question is, okay, now that hopefully I've convinced you it is actually race-based, what are the reasons that this is happening? Like what in the underlying machine learning mechanism is causing this bias? So I'll start with answering that first question. How do we actually know these are racial disparities? So I'll show you now the 3 cities on the left are where we're sourcing our Black speakers from the Coral sociolinguistic data set. And the 2 on the right are where we're sourcing our white speakers from. And so you might say, you know, kind of eyeballing it, these kind of make sense with what we expect based on the high level, what we saw, you know, the word error rates are much worse for Black speakers. But there are some question marks here, right? So it seems like the Black speakers from Rochester have very comparable word error rates to the white speakers from Sacramento. And so the question there is, well, what if this actually has nothing to do with race? What if it's just a location-based thing? Because people in Rochester all seem to be doing fine in terms of their word error rates. So in order to discuss this more, I'll be introducing 2 different linguistic terms. So I'll be referring to the way that the Black individuals speak in our sample as African American Vernacular English. Not all Black speakers speak AV, but we will be using that term as opposed to things like African American language or African American English. There is kind of ongoing lively debate in the linguistics sphere in terms of what are the best ways to describe these forms of English. In keeping with John Rickford, our co-author's preferences, we are referring to this as AV, so African American Vernacular English. And in contrast, when we talk about the variety of English that white speakers in our sample are speaking, we use the term Standard English, which in fact does not actually refer to desirability, but rather just the grammatical features and the way that they speak. So this is kind of what is done in the linguistics sphere, and so we keep with the existing literature. So we have AV and Standard English. So now that I've kind of introduced those terms, why does this matter? So we're going to introduce a new metric in order to kind of figure out whether this has to do with race. So to start, AV is spoken about by about 80 to 90% of the Black population in the US. So one thing we can do is basically count how many AV linguistic features exist in a few different voice samples that we've collected. And we can do this by geographic location. So what exactly is an AV linguistic feature? We have a long list of both grammatical and phonological examples in the appendix of our paper. I won't go through all of them here, but as one example of a grammatical AV linguistic feature, we have the 0 copula. So in quote unquote Standard English, we have the sentence say, they are gone. And in the AV formulation, you would remove the copula, which is R, A-R-E. And so then you're left with they gone, which is the AV formulation. There are also phonological examples. So things like final consonant cluster reduction, so band becomes ban. And so again, what does this actually sound like when you put it all together? I'll play you 2 different clips. So the first one is an example of a Black speaker that has fewer AV features in their snippet. You can already kind of see this has a very low word error rate, so high accuracy. the ASR service actually only messed up on one word here. And the blue highlighted word is the single AV feature spoken by the speaker. And this one is going to be syllable initial fricative stopping. So the D is going to sound more like a D sound in the beginning.
Grow older, we get darker. So I was extremely light when I was a child and very skinny. And so I was like an outcast because I was made fun of because I was the white girl at the school.
All right, now in contrast, I'll play you an example with more AV features, and you can already tell that the word error rate is super high. It's over 50%, so basically unintelligible if you were to only look at the transcription that was given to you as opposed to the ground truth. And you can also see that there are many more blue highlights, so many more AV features.
Because our second grade teacher gave me the nickname Snake, because she said I was sneaky, I'd be sitting one place and she turned around, I'm sitting someplace else.
All right. So hopefully you can kind of suss out where I'm going with this in terms of looking at the amount of AV features in conjunction with the word error rates. So if we look across many different snippets, where each dot is one voice snippet, we see that there is positive correlation between this dialect density measure, which again is basically the share of words that have some sort of AV linguistic feature, grammatical or phonological, against the word error rate, where again, high word error rate is a bad transcription. So bringing this all back to geography, I'll show you the exact same graph, but now with color. Basically what we ended up seeing is that Rochester, which was our big question mark before, does have low word error rate, which we knew already, but also it has very low dialect density measures across the board. So really not that many of our speakers in Rochester are using many AV linguistic features. In contrast, for example, in Princeville, North Carolina, there's this huge spread of dialect density measure where many more of them are using many more AV linguistic features in their average speech, and that ends up correlating with much higher word error rates. Okay, so going back to our initial thought, it does seem like what the actual thing to be thinking about here is not actually just the black or white dichotomy, but rather the spectrum of how many AV linguistic features are people using, where it turns out that folks in DC and Princeville are speaking with more AV features, people in Rochester are speaking with fewer. And one other note I'll make about the geographic variation is that we did try to have some spread in the locations that we looked at. An obvious question is like, why don't you just look at the same place and then within the same city have both black and white speakers? Unfortunately, it's very hard to find existing data that does that, that is already pre-transcribed with the ground truth that is controlled for reporting quality in the way that sociolinguistic interviews are. So unfortunately, that data just isn't available at the scale that we need it to be. So given that we have to look across locations, we do have both rural and urban locations for each of our black and white speakers. So we know that, for example, for white speakers, the rural and urban folks do have a comparable word error rate and that sort of thing. The other thing to note that's interesting about AV is that AV is actually a national dialect and not a regional dialect. So no matter where you go in the US, your AV linguistic formulations, so those things like zero copula or syllable initial fricative stopping, are going to be roughly the same no matter where you are. And so, that kind of layers onto wherever you are in the US. Another kind of final interesting note that I'll end with on this note about geography is that AV actually shares a lot of linguistic commonality with Southern accents. So you may have heard that like, oh, if you speak with a heavy Southern accent, Siri is also really bad at detecting that. AV can be thought of as basically that, but even harder for an ASR to understand. Linguistically, they are quite similar. Okay, so with that, I will turn to the next big question, which is basically, okay, we've decided that these ASRs are clearly tripping up on individuals who use more AV formulations in their speech. So why is this actually happening within the ASRs? So it would be great if we could actually look under the hood at each of these 5 companies and determine like, oh, Google is doing this, Microsoft is doing this. Unfortunately, we cannot do that, or at least at the time of us writing this paper, none of us were affiliated or embedded in these companies, so none of us could. So what we had to do is basically rely on external knowledge or the most up-to-date literature on how ASRs actually work. And the way that they do, most ASRs do, is they're comprised of 2 separate components. So the first one is the language model, which you may have heard of things like GPT-3, that is a language model. And this deals with what you're saying. So this is going to be things like models of lexicon and grammar. And the second thing is the acoustic model. So this deals with how you say things. So things like phonology and phonetics, or other patterns of stress and intonation. So we know that all of our 5 ASRs probably have something to do with one of these two, or both of these models, one language, one acoustic, that we don't actually know any of the details about, what's going on within the language model and what's going on within the acoustic model for each company. But what we can do is run a few tests and try with process of elimination to determine whether it is the underlying language model or the underlying acoustic model that's leading to the disparities that we find. So how do we do this? Let's start with talking about test 1, which is on lexicon. So the idea here is basically, let's say that all of our Black speakers have cats. They love their cats. They talk about their cats all the time. Meanwhile, all of our white speakers have dogs. They love their dogs. They talk about their dogs all the time. Now, if it is the case that Google knows about dogs and dogs are in their vocabulary, they're well aware of dogs, but Google has never talked about cats and Google has no concept of cats, then it ends up being the case that whenever Black speakers are talking about their cats, Google will mistranscribe that as, say, dog, and so that will increase the word error rate. Whereas for white speakers, they'll talk about their dogs all the time, and that's fine because they get transcribed correctly as talking about their dogs. So what we can do then is figure out whether there is this kind of vocabulary gap for, say, Google, where they are disproportionately not knowing the vocabulary that's used by Black speakers relative to white speakers. Now, again, it would be great if we could just go to these 5 companies and say, hey, tell me all of the words that you know, what is in your dictionary. Unfortunately, again, we can't because that is, a secret internal knowledge, but we can approximate those dictionaries pretty well by being a bit clever about the fact that we've actually, just run a bunch of transcriptions on 40 hours of speech data. And so they have transcribed a bunch of words. And what we can do is just take the union of all of those outputs, all of those transcriptions, and basically generate a pretty robust dictionary, because we know that if they have output this word before, they must know the word. So we basically first reconstruct all 5 of these different ASR firms' lexicons by looking at all of the words they've transcribed. And then we calculate the share of words that are actually known, out of the words that are actually known, that end up in our corpus that are spoken by each of our Black and white speakers. And what we end up finding is that basically 99% of all of the words that everyone spoke were known and were in fact in the Google and Microsoft and so on lexicons. So basically, we don't think that the lexicon issue is what's leading to the bias that we see between white and Black speakers. So the next question to figure out is, okay, well, if it's not lexicon, maybe it's grammar. So in order to test that, we're going to introduce one more metric, and that metric is called perplexity. You can think of perplexity as a metric of confusion. So let's say that you are GPT-3, you are some language model, and someone tells you the first few words, the dog jumped over the blank. Now you think to yourself as GPT-3, and you say, okay, well, I think there's a 5% chance that the next word is fence, 2% cup, and 1% moon. Then if it shows you the next word and the next word is actually fenced, you'll say, oh, okay, I'm not very perplexed. I had a high guess that, the next word would be fence, so I'm not confused. That means I have a low perplexity score. Meanwhile, if the next word was actually moon, GPT-3 would look at that and say, that's very confusing. I did not think that the next word would be moon, and so I'm highly perplexed. I have a high confusion score. So with that, basically what we can do is calculate the perplexity scores for each of our black speakers and each of our white speakers, and figure out what will happen. Now, recall that I gave you the example of the 0 copula before. So in this sample table, we basically just took canned phrases and fed in both the standard English formulation as well as the AF formulation of each of these sentences into our GPT. At the time, I think it was GPT-2, because GPT-3 wasn't out yet. And what do we find? So basically, when you input he, a pastor, into GPT-3, it's very high perplexity. It's very confused about this grammatical formulation. Whereas if you input his, a pastor, with the apostrophe S, with the copula included, you get very low perplexity, so low confusion. And this is true across the board, where GPT-3 appears to be less confused with the standard English formulation of phrases as opposed to the AV formulation of these grammatical phrases. So what do we actually see? So again, this is on like canned data that we input into GPT-3. So what happens when we put in our actual data? We actually get the inverse result. So this is very confusing because we aren't expecting this, given that we put in a few dummy examples and they seem to show us the opposite finding. So why do we get this surprising result? This is likely because the Black speakers in our sample uttered on average fewer unique words relative to white speakers. So basically, let's say that instead of being a very fancy model, GPT-3 was just a random word spitter outer based on the number of words that it already knows. And so if GPT-3 is trained on, something that only knows 3 words, then the next word that it guesses, if it guesses uniformly randomly, it has a 1 1/3 chance of getting it right. Meanwhile, if GPT-3 has seen, like 10 different words before, then it only has a 1 in 10 chance of guessing the next word right if it's guessing uniformly random. So it's kind of the same concept here, where basically because the Black speakers are using fewer unique words, our language models will pick up on that and basically be able to guess more accurately what the next word is, regardless of the grammar. So it doesn't appear that the language model overall seems to be the reason that we end up with all of this bias overall when we look at our word error rates when comparing these transcriptions. So with that, now let's do our final test on phonology and figure out kind of what's going on with the acoustic models. So in order to do this, we need to find both Black and white speakers who are saying the exact same thing in our sample. Now, how do we do that? This goes back to why it's very nice that we have sociolinguistic interview data, because you might recall that the interviewers are asking roughly the same types of questions. So things like, where did you grow up? What did your parents do for a living? And so we end up with a lot of n-grams of people responding with very similar phrases. So things like, and my mother was a, probably fill in a job, because that's a common kind of sociolinguistic interview question. And so what we can do is basically match the voice snippets of the Black and white speakers uttering these same phrases and see how well the ASRs are able to transcribe those same 5 to 8 word phrases. And what do we get? Hopefully this chart looks roughly familiar to you, because once again, we've recovered this doubled word error rate between Black and white speakers, where again, these are on the exact same matched phrases. So it does seem to really indicate that the acoustic models are at fault here and are the source of our bias. So a really quick summary of what we've found. Firstly, all 5 of our ASR systems that we studied exhibited racial bias to the tune of doubled word error rates for Black speakers. And secondly, we do trace this to the acoustic model, which does seem to mean that for whatever reason, ASRs are really bad at picking up the differences between standard English and African American vernacular English with regard to things like rhythm and pitch and syllable accenting and that sort of thing. So now what? I'll go through a few calls to action and then talk about kind of why I think this work is especially relevant in these days. So first, our call to action is we need to collect more diverse data, right? One big issue is that a lot of the original training data for these 5 different companies is most likely, majority standard English, standard white American speech. And so both AV speech and other non-standard varieties of English do need to be collected in order to make the speech-to-text services actually work better for everyone. The second thing is that this isn't just a data problem, this is also a people problem, right? So if you have diverse people in the pipeline working on these products from start to finish, you don't end up, shipping a product that clearly is biased and harms lots of people. And so the speech recognition community really should invest more in not just the data, but also the people. Next, it would be great if the people developing these technologies regularly assess their products and publicly report progress. So hopefully our paper can serve as a model for figuring out how to do that publicly. And lastly, it'd be great to learn from kind of progress made in other domains. So if you'll recall from the very beginning of this talk, I mentioned the gender shades paper, which found that facial recognition was biased and yielded poor accuracy for women with darker skin tones. And the result of that was a lot of positive progress in terms of interfacing directly with the government and big tech. And so in the context of, 2020, they did at least kind of temporarily, I think, result in IBM and Microsoft pausing their facial recognition technology being sold to police. So what is the analog here? What is simmering on the legal side with regard to speech to text? So one big concern is that the ADA is violated if speech to text is in fact biased, because individuals with disabilities need to be treated fairly. There's another kind of set of issues in the legal realm, and the rest of my examples today will be all kind of in the legal realm. Given that 12% of the US population speaks some degree of AV, we need to expect that AV will appear in some capacity in the courts, right? And so here's one example that has nothing to do with AIs and just has to do with humans. This instance was obviously malicious, but you can imagine how a ASR could very easily make a similar mistake. And the question is, what do you do then? Another kind of pernicious issue is surveillance. So this is based on a story that was recently written about a particular firm. This is a screenshot directly from the firm's website, where basically they wiretap prison phone calls, and then they analyze these calls. What actually happens is they're using the Amazon transcription service, so one of the 5 firms that we evaluated in this paper. And the funny thing on their website is they claim that there is no implicit bias and no racial profiling, because they just analyze the output of the Amazon transcriptions and then make some decisions based on that, which of course could be very harmful to incarcerated people. So that is another example of, alarm bells should be ringing about possible, bad uses of ASR. And another example I'll give is on court reporting. So currently, because of cost-cutting reasons, a lot of places are replacing humans with ASRs. And of course, the key question, I like this quote, is not whether ASRs can actually do better than humans, but what is actually fair, right? And unfortunately, we have a really difficult problem to solve here, because we know that ASRs are biased. Hopefully I've convinced you of that in this talk. But we also know that humans are biased, right? It started with the lawyer dog story, but here we also have a study from 2019 showing that human court reporters, including those who were Black, did not actually meet the level of accuracy they needed to on AV speakers relative to white standard English speakers. And this is especially bad when it comes to things like court reporting, where it's very easy to basically, mistranscribe things like double negatives as a single negative, which will totally invert your actual meaning. And so these are all things to kind of consider when it comes to thinking about ASRs in the real world. And so to recap, within lots of applications, there's a lot of work to do, but especially for figuring out the right role for humans in the loop, right? It's very easy to point fingers and say like, oh, ASR is biased, so just don't use it. But at the same time, there is room for it to help, but there's also room for it to hurt. So what is the right balance? And so I'll end this talk and leave you with an open question, which is just who should decide what the ground truth is, right? What should we do in all of these different contexts with regard to ASR? All right, and with that, I will open up the floor to questions. I will also mention that there is this cool website, fairspeech.stanford.edu, which has a bunch of voice snippets that you can actually click on and listen to and see where the ASRs are messing up on the different snippets, if you're interested in that. Yeah, that's it for me. I'm happy to take questions.
Thank you, Allison. That was really fascinating. And I guess I'll throw out a question. Has something similar been done for the Hispanic community in all or in particular parts of the US? As I imagine that, some other groups of population in the US also experiencing a lot of challenges with these speech-to-text systems.
Absolutely. Alicia Wasink at UW is currently doing a lot of the work focusing on the Hispanic community.
And another question would be, now that you're at Microsoft, does Microsoft see themselves as, responsible for working with these other companies to make this more public, or to work with the other ones to improve this and collaborate in some ways so that researchers can really, as you said, it was very difficult to do, that it would be easier to kind of test themselves against each other?
It's a good question. I don't know of many big tech companies that are collaborating across themselves. I will say that Microsoft is individually taking this particular issue very seriously. And for each of the companies, there are kind of serious downstream effects, right? Because again, these are their APIs that are being used by other companies. So for example, the prison phone surveillance company is using Amazon technology, and similarly, there might be issues with downstream consumers using Microsoft technology. So in terms of those collaborations, kind of with downstream consumers, I think Microsoft and probably all of these firms are dedicated to making sure that there is some sort of oversight in terms of is something bad being done here. All right. I'm going to read this question out loud then. All right, one question. Now that you found out what is causing the bias, vowel duration, rhythm, pitch, etc., do you know why those models don't learn those two for Black speakers? Is the data to train those models coming mostly from white speakers? You have answered your own question. Congratulations. That is exactly the issue. Basically, the crux of the issue is that there's nearly no training data on quote unquote incorrect kind of formulations. So if things are pronounced differently than the standard English American way of pronouncing things, often those don't make it into the training data. And so that is likely where a lot of the issue is coming from.
Hi, I have a question. I really love the talk. Thank you for, discussing this, because I feel like this is like one of the least talked topics out there. My question was, do you think somehow there's an inherent bias in the researchers, the feature engineering part when they were developing the model? Maybe somehow the bias of the different models might kind of seep into the model, and then that like translates to this racial disparity. And what do you think, like, how can we minimize that bias? Do you think that would reduce if we hire more diverse researchers to work on such projects?
It's a great question. And again, one that's kind of tricky to answer if you're external to the company, because otherwise it's hard to see what people are actually doing and what people are messing up on. Again, I guess I will say that I do think the crux of the issue is less on the actual feature modeling and the specifics of what's in the model, and more on the training data and the fact that the acoustic model in particular is just unable to kind of generate any sort of notion of things that aren't standard kind of American English. And so I think in terms of, my pitch that one of these calls to action is that this is a people problem and not a data problem, and not just a data problem, is that if you have more people in the pipeline to say, hey, we need to collect more training data, that's super important, and really goes hand in hand with making sure that your models themselves are actually fair in terms of the features. And I do think that there is some amount of thinking about this already, in terms of the fact that some of these companies have specific kind of buttons that you can toggle on and off for example, accented English for non-native English speakers. Like these models exist, but they aren't necessarily being kind of ported into the final product very well for a lot of these customer-facing services. So hopefully that answers your question, and I've seen more questions pop up in the chat, so I will continue to read them out loud and answer them. All right, from Divya, are there any ASR systems one question that I get a lot is usually like, oh, but like if you were to feed in a bunch more training data for, say, Black speakers, wouldn't that negatively impact the accuracy for white speakers? And the answer is probably not, because you could do exactly this, which is that you can just make an ensemble model where you wouldn't end up hurting the average accuracy for a different group. In fact, you would probably bring all accuracy up, because again, with my example of AV being very similar to Southern dialects, by having more AV training data, you would probably help the white Southern accented speech word error rates as a result. Going backwards again, let's see, from Asavari, thank you so much. Do you think a single model can accommodate multiple dialects, or should we train different models for different dialects? That is still very much ongoing work. To my knowledge, I think people do tend to look at using different models for different dialects, in that now when you go on the Amazon or Google, for example, APIs for their speech to text services, you can actually select specific subtypes of English. So for example, you can select English, but in Australia, English, British, English, Singapore, and that sort of thing. And so it does seem like, at least based on what I can tell as an external consumer, that they have each of these different models, and likely what they're doing is doing some sort of ensemble afterwards. All right, John Luca, you're here. Hi, John Luca. Okay, I will read the question out loud. Is this issue common to different languages internationally and with different dialects? Great question. I imagine any place with kind of high variance within their kind of speech patterns would likely face the same issue. The reason, or one of the reasons that we focused on the specific case of AV in the US is because of its prevalence and also the kind of important socioeconomic impacts of the Black population specifically, right? Where we do have this situation where, like I mentioned, the number is something like 12% of Americans speak AV in varying degrees. And so that kind of large share of this particular variety of English is what inspired us to work on this. But I imagine kind of there are probably similar takes in other countries as well, but I'm less familiar with non-English ASR systems. Okay, John Lucas, statement number 2. One of the simplest tests with Google Translate is to feed back the answers and check if the inverse translation is possible. Is there a similar loop possible here? That's a great question. Probably not, because I feel like the like Alexa equivalent who would then read out loud the statement that was transcribed, they have actually tested doing like the voice assistants with different accents. It has not gone over well in consumer surveys. I think people feel a little weird when you know, Alexa doesn't sound like Alexa the way that we are used to her sounding. In any case, I think there's probably been less work on basically having a model read out speech in a certain accent relative to understanding and transcribing it, but I might be very wrong there. That is my understanding of the current state of things, though. All right, any other questions?
I had a follow-up question to that. So, so you just said there have been like negative feedback to, I guess, like people changing accents if Alexa sounds different and stuff. So when so I guess I do, like as a consumer myself, I see a lot of ads for when they introduce a new voice for like these ASR systems. And are these voices technically then trained to only speak in the standard English, and that's what's passed down to speakers? Because I've not tried them out, because like you said, I just prefer Alexa to sound like a computerized voice, I guess. But say if they chose a Black celebrity to do that, would that sound different? Or are they still forcing them to, I guess, sound the same?
It's a great question. Well, I mean, even taking race out of the picture, there are like the voice assistants that do British accents, and there are voice assistants that do American accents. And so you already have that kind of difference, and that the defaults are different. I believe I read an article relatively recently about the potential rollout of a Black, slightly AV-speaking voice assistant. And I think the thought was that could be interpreted as kind of pandering to certain segments of the population if they do that, but also it could be interpreted as kind of a serious effort to include diversity. So I think jury's still out on kind of the race-related specifics of it, especially in the US. But past that, most of what I'm familiar with in terms of, you know, different voices for different voice assistants, which again is kind of not my area of expertise. Point being, there are different voices that you can try. People tend to like the thing that they chose. Yeah.
Any last questions? Okay, well, thank you again, Allison. That was really fascinating and learned a lot here. So, and thanks for leaving your email up if anyone has any follow-up questions. We'll also share the video with everyone in the class afterwards if you want to review it at your leisure at another time. And we'll have that live transcription with closed captioning as well. So, okay, well, thanks everyone for coming today. And again, hope you can join us on Friday at 3 o'clock for the SAP cybersecurity session. And thanks again, Allison.
Thanks so much for having me. Have a good one.
Stay warm.
Thank you.